Welcome everybody to Tuesday night. I'm your host, MC Toon. And tonight we have in store a debate. This debate is a little different than usual. Usually it's a debate on flat Earth. This is a debate only peripherally about flat Earth. It's about general relativity. Now, the reason why it's peripherally about flat, I keep saying it right. I hope I can keep it up. The reason why is because flat earthers think that if they falsify general relativity, then automatically they think then the Earth becomes flat. But nothing could be further from the truth. There's a good number of people that reject both special and general relativity and are not under the delusion that the Earth is flat. So to that end, it's more of an academic type of a thing because they still can't explain how the sun sets. You know, what time will the sun set tomorrow? For any location, any day. Doesn't have to be tomorrow. They can't explain it. I was talking to Indio 007. He's no secret agent on Twitter, X or Twix. And he's something about, you know, the sun could never set. He's like, oh, it can too. I said, well, cool. What time will it set tomorrow? He can't answer, right? So he does say the equation of time. There, I proved it to you. Like that didn't tell us anything about what time the sun will set. The equation of time is a non-geometric way to determine where the GP of the sun will be. It's derived from geometry, not flat Earth geometry. So, Demonic Leprechaun. Yes, the person I'm debating is a flat earther. Alan/Space Audits is, and it's on Jeran's channel. So, anyway, so where was I? I was talking about Indio. So he says the equation of time is that all that does is determine where the sun will be at any point in time. And you can have that on any particular projection because it gives you the latitude, longitude. And he's like, oh, the Gleason map, that's why it's patented. Like that. None of that explains what time the sun will set, because the important part of the time that the sun will set is when will it cross the horizon? And on flat Earth, it's different for every position of the flat Earth and every day of flat Earth, what time the sun will set in relation to how far you are from it. So it's not too far away it sets. It varies dramatically on flat Earth. There's no geometry to explain it. That's why it's such an easy destruction of flat Earth to just say, what time will the sun set? If you can't do it, then your model's falsified. And by the way, we can do it using globe geometry. So, PhD Tony says gravitational time dilation has been observed on Earth's surface in atomic clocks over a separation as small as 1 millimeter. Case closed. Can we go home now? Tony, that will definitely be one of the things I will probably bring up. I can't be both definitely and probably. I have it queued up. I have a few of them queued up. So I don't know. So here's the format. We each have one particular topic of general relativity that we're going to talk about. We're going to present each. We get a 12-minute presentation and then a rebuttal. And we get a question. We each get a question. I haven't written my question down. I'll get on that. When shall I get on that? I shall get on that right now. I need to pull up. I've been working on this. This is a pretty good. I like debating this topic. It's more interesting in some ways. So all right, the way it works: interlocutor A, 12-minute presentation. Interlocutor A, 30-second question to interlocutor B, who then has a 1.5-minute response to that question. Then interlocutor B gets 12 minutes to respond on topic, followed by a 30-second question to the other person, 1.5 minute response, and then a 12-minute exchange. Total of 40 minutes. We both do that. That's a total of 40 times 2 minutes. And then the rest of the hour and a half, rest of the 2 hours is Q&A. That's about it. So it should be easy. It keeps it on topic. My topic is bending of light deflection specifically. And his topic, so I will be presenting evidence for light deflection. And his topic is gravitational redshift. And he's going to obviously debunk every single gravitational redshift experiment that's ever been done. I'm kidding. I don't know what he's going to do. Anyway, I thought I would get out the book. Hold on. I have a lot of books here. Just a second. This one. Here we go. This one. Right here. And then, hold on. There we go. This one. These two books. Great books. Both of them. Fantastic books. I've read them, and by read I mean listen to the audiobooks, and gotten my hands on the paper a little bit. This one once, this one twice. So this one I like a lot. It's really, really good. I highly recommend it. I don't get anything from this. Daniel Kinefek. If you have a way to talk to him, send him a message, say, I want to interview him. Anyway, no shadow of a doubt. I've listened to it twice. In fact, during our trip to Texas, to the eclipse, we listened to it a second time. So there it is. All right. Now, Jeran has messaged me. I mentioned it earlier. He is getting ready. So the question I should ask to Alan on the topic of gravitational lensing or light deflection. What's a good question to ask him? He only gets a minute and a half to answer. So it can't be super complex. Probably something along the lines of I don't know. What do you say to the fact that that there have been positive measurements of the shifting of stars? Anyway, then I also get to ask him a question on the topic of gravitational redshift. So, Oh, Peachy Tony, genius. How do you explain Einstein's rings? That's it. Nailed it, Tony. Thank you. For redshift, gravitational redshift is exhibited in a few ways. The main one that is tested is in clock ticking. Clocks tick slower. But there's others. There's the Pound-Rebka. So my guess is that he might try to refute Pound-Rebka, which is one of many, many different redshift experiments. So, but I don't know. Refuting one doesn't refute others. So it's definitely harder for him to refute all redshift experiments. So I mean, basically, one way to do that would be to have to cover an entire regime to say, well, if here is what actually causes it. Here is the hypothesis and the empirical measurements for why redshift happens in some other way, right? You'd need actual real confirmation of it, and I don't think that will be forthcoming. So. Yeah. So Tony, how do we explain wavelength changes of different magnitudes from white dwarfs of different masses? That's tough. That's a tough one. Ooh, the Zoom call is waking up. So, I might do that. But yeah, so Tim Davidson asked him to explain Einstein's cross. which is also like Einstein's ring, right? It's just a specific. Yeah, I like that. Yeah, I think Einstein's cross, Einstein's ring, the cross is a little more specific, isn't it? Right? That's very specific. It's one thing. How do you explain the one thing? So, all right, I'm gonna focus a little bit on them because I'm popping in. Are you there, Jeran? David Lee says, "Hi, Mike. Glad to see you made it home safe." Thank you, David. I did. It's been a week now, so.
Thing they added to Zoom.
All right. Well, I'm glad you hit the unmute button, Jeran.
Thank you.
All right, so I'm live right now, so don't burp.
Oh, okay.
Gotcha.
You're on my best behavior.
You're not on screen yet. They'll hear you though. If you burp.
They don't have to see me. I'm still setting up. 1 second. I was working out in the backyard. Now I'm all sweaty. It's all fun.
I was kidding. You can burp.
Okay, thank you. I usually don't do that, but. All right, so we got this.
All right. Here we go. I'm gonna get your live chat up on my my stream too, Jeran.
There we go.
So if anybody's naughty, they all see.
Yes, I'm sure they're worried about that. Let's see.
Your concern.
Oh,
I like your concern.
I can only police myself, right?
Yep.
Okay, good. Just making sure. About the best I could do.
All right.
What's up, Alan? You look very spacey.
Yo, what up, G? What's up, Tune?
Hey, Alan, you got a little haircut there.
Yeah, a little beard cut. Little beard trim. Yeah.
There you go.
Yeah. I trimmed it. I was trimming it last night, and then I didn't have the guard on, and I accidentally went zit. So I had to lower it a lot. So
Are you
yeah.
serious?
Yeah.
All right. Now people can see you. They can see the beard, the less beardy face.
The lack thereof. Yeah. It's in a different reference frame or whatever the kids say these days.
But that's definitely what the kids say. Oh, Copper and Quarter says, "Happy birthday, Judy. You got this."
Who the hell's that?
Judy, you got
Happy
this?
birthday.
Or Copper and Quarter. Well, they're people on my channel here. Judy's around a lot, and Copper and Quarter is maybe a year or 2 years ago new. He does.
Judy, huh?
He has a channel where he extracts gold and other precious metals from like circuit boards. It's pretty cool.
Oh, that's cool. From like computers and cameras and stuff. Make some money that way.
I don't know.
Or just more for fun.
I don't know. I don't know how much he makes. I have of course a large supply of circuit boards through my work, and I have done some gold extraction attempts, but then I get partway through and I'm like, okay, now what? And then I stall and I park it, and it goes a year in a bucket, not touching it.
You ended up losing money, basically.
Well, I didn't pay anything for it. It was thrown out from work. I just had to take a screwdriver. Well, yeah.
Yes. How was Ultimate Frisbee? A lot of cool people will play.
It's always good. I love Ultimate. Yeah.
But like disc golf or whatever?
No. Ultimate Frisbee is like, it's more like keep away. It's 2 teams, and then if you catch in your end zone, it's a point. And if it hits the ground, it's a turnover. Or if they intercept, it's a turnover. So
Gotcha.
Let me can one of you guys share just to make sure it works?
So I have it set up so I don't have to screen share.
Okay, cool. So you show your screen.
That's nice.
Yeah.
I will be screen sharing, so give me a second here.
Yeah, so mine will transition into that if you're able to give me like
Sure.
yeah.
So
So okay.
like this kind of screen, it would be the whole
Yep.
Your whole face. Okay. And then we've got left
There you go.
side.
How's that?
Zoom, media, oops,
You see that, Jeran?
Oh yeah, hold on. Oh, I see it. Wait, is it incognito window?
Yes.
Yeah.
I thought that was my window.
Oh,
Like I can't find it. I only can find the browser. No, it's you. We're good.
all right. Well, you see it then. All right.
We're good.
Oh my goodness. Upside down guy has a comment that I will not be reading.
Oh no, what is it? It's not about me, is it?
No, it's about Alan's beard. Upside
Oh
down.
no.
I will
You're
just
good.
I will just mention
You can say it.
that's weird. No, it's too weird.
Well, it's weird that you've said it that you're not saying it now. So yeah,
I know.
now I feel like you
No,
have to say it.
Yeah. All right. He says, do you want to muff dive space audits beard? I do not.
Nice.
Wow.
Or no, wait, that's
I
not.
left that
It's
alone.
not nice.
You said muff dive.
He did.
Okay. I don't know.
See? Now you know I didn't want to read it. That's too weird.
Yeah.
Yeah.
Oops.
All right, let me read this one here.
Did
All right, Icy
he
Spin
send
says
money for that?
grant him relativity debunked so he can explain flat Earth. Yeah, that was $2. That was a $2 super chat.
He donated to the McToon Fund?
Well, it's not a donation.
Oh,
It's more of a tip, I suppose. Because
Is there a difference?
I'm not a 501c3 charity. You can't donate.
you can donate. You can donate to your neighbor if you want.
Yeah, but I don't know.
I mean, it depends on how you classify it, right? Because they redefine all that stuff every couple years anyway.
I don't know. I
wouldn't
I
know.
have to file a Schedule C. That's
File
all
it.
I know.
Yes.
Did you file a Schedule C?
I just do self-employment income, and
Oh, okay.
then I have to file with, I don't know, Patreon and
Yeah,
Google.
yeah. All right.
Oh, that was Schedule C. I don't.
Jess says, my first live
The Patreon,
MC
yeah.
Tune debate. Been binging your debates the
Oops,
last
sorry.
few days, and I'm loving it. I work with vets, so
Let
thank you to all the vets in the service.
me say hello to the
Thank
vets.
you
I'll
for
give
that.
2 minutes. 2 minutes, and I already got my water and already got my drink, so I don't even have to get up for that. How about that? How about that for thinking ahead?
2 minutes. All right.
What do you guys think of the debate today?
That was,
Dude, it was-
what's your favorite word, Jeran?
Interesting.
That was true. Yep.
Interesting can be it. Where's my?
What'd you think, Alan?
Oh yeah, it was dope. It was nice.
You were running on your channel, weren't you?
Yep.
Yeah, I saw it when I woke up, right as it was ending. It's typical of me. West Coasters. Yes, this one.
I liked when Alex Jones popped in. That was funny.
That was.
He was like, it's definitely spheres in the sky, guys. End of story. I seen him. That was funny.
Funny guy. Funny guy.
All right.
All
Lord
right,
Illuminous Poo says, lick
where is
the
the
like
live?
or get licked by me.
So you want to just walk me real quick through whatever your little plan is? You said there is going to be an intro or something? Do we need a coin toss?
Oh yeah, coin toss, and then you just want to send him a screenshot. I could do it actually of the,
I got the one. I
format
think
you sent.
but I didn't know it didn't say an intro or anything.
Yeah, there
I mean,
wasn't an intro, but I mean, we can say hi.
yeah, just whatever the standard stuff you do, and then we'll get into it.
Okay. Gotcha. 1 second. That's good. All right.
Whose sound is pretty low, Flurf Hunter?
I'll send out a telegram as soon as we hit the go live button. Restream
Only the
ready.
Jeran and the Marble Mouth is lowish.
Refraction is ready.
Yeah.
I should have had the AI write a song about your guys' debate tonight.
Oh, dude, the AI is so good at writing songs. It's funny.
Soon
It writes the best stuff.
Yeah, it's like actual like good music, good beat, good catch, good hook. I mean, I think every bit of music that's been written probably the last 10 years has been AI. So good.
Well, don't they say it comes from like one person anyway? Like one dude writes everything for everyone, apparently, or like two people.
I don't know. Isn't it kind of a collection of knowledge?
I guess you could look at it that way.
It's just 4 chords. That's all you need.
4 quarts?
4 chords.
Oh, chords. I don't
Right?
know that much. Is that all you need to write a good song?
I
think so.
Yeah.
Wow. I think I'd be able to play the guitar then. I cannot. All right, Rockman, I was on the wrong account. That's the problem. Setting it up on the Glowbusters.
We're going on Glowbusters?
No, I'm changing it.
Okay.
But they had it set up on Glowbusters. I forgot yesterday was Sunday or day before. All right. So we get that. Count. Oh, this one. Okay.
All right.
Here we go. We are going to get started. You guys your mics are open during the intro, so pipe down.
I'll mute myself.
And let's make sure we
Pipe
got
down, he said.
ready. Yes.
All right. Is Alan's audio and my audio good? So that's the one thing I need to make sure is set correctly.
Go here with this. All right. Sounds good. I'll post something on Telegram. Is that it? Yes. All right. See you guys after the intro. It's not too long, but it's not too short either. All right.
And I won't subject you to that
Here's
intro.
our live in. There we go. 3, 2, and 1. Have fun, guys. Yelling, streaming. All right, here we go.
Okay. Yeah, he said all good music written within the last 10 years is AI. To my knowledge, AI has only been making music very recently. So jazz hands. All right, audio levels are good. Wait, we're getting from a few people. So awesome. Whatever. Speaking of Austin, after this live stream, I will be doing a review of the debate from earlier that Austin and Harrison from Alex Jones's network were on. So be on the lookout for that. Then on Friday, I have two debates on Friday. I'm on Modern Day Debate with Corey, who challenged me to debate gravity. Hey, this light is off. Hold on a second. Here we go. How's that? Corey challenged me to debate gravity on Modern Day Debate. Doing that there. And then after that, Captain Cook will come back. Captain Cook. You know him, concaver? He's no longer a concaver. He's now a flatty, and he's bringing his e-girl with him. Whatever that means. Whatever that means. Steve6464 says, but there are only a few people writing all the modern pop music. Could be. I don't know. Most of it's junk. So gravity isn't a debate. You're right. All right, and I'm supposed to call tails in the flip. I'll call tails. Now, normally this is where Jeran shares his intro thing, and I'd neither hear it nor see it. So he is saving us all from that nonsense. And he is, in fact, live now, so I don't know why I don't see him. That's all right. That's all right. They believe that Photoshop existed in the 60s, so it's consistent for them to believe it existed a decade or more before it did. Yeah, that's true. That's totally true. The family just got home and got the puppy. Donkey likes to sit down underneath the why can't I say desk? Likes to sit under the desk. So okay, I hear now. Here you go.
What you're seeing here.
So a little bit of the clip of Jeran's intro that keeps getting longer, it seems. I don't know. Do you think that AI wrote all of Dragon Force's music? I don't think so. All right. Oh my gosh. The audio the intro just keeps going. Oh, I know I didn't hear it because Zoom removes music. You can't, for compression, you don't hear it. So. Oh my goodness. Oh my goodness. All right. Think he's getting close to no, oh, there's another song going. My goodness. Real Sickness, Rush for the win. I don't know if Rush, did they have any new songs or albums in the last 10 years? They kind of stopped writing after somebody died. All right.
Ready. We've got another debatism for you this evening. It is on to episode number 23 of the regular type. We're not doing debatism X tonight. We are doing debatism with self-submitted formats, which is weird, but nonetheless, it is going to happen. It is episode number 23 on the 23rd, and that means something. I don't know. We'll have to ask somebody who's into numerology. What does that mean? It is April 23rd. If you're watching this any other day, it's not live. If you're watching it on the 23rd, it's live. We've got MC Toon going against Alan from Space Audits. Let's bring them on, and we were almost ready to do that, but not quite yet. Give me 1 second. We will get this done. So if you want to support the guys or support me and ask them questions at the same time, we can do that. You just go to Super Chat on YouTube, or you can go to Rockfin and send a tip, and I will ask the guys at the end of the debate whatever question you want me to. So that's coming up at the end, and I guess we can have Alan here. There we go. We'll have Toon come on first. Toon, go ahead. You can say hello to everybody while I fix Alan's screen. Just take a second.
Hello, everybody. I was just informed that I ladle manure. It's been a while since I've had to do that, but welcome everybody. Thank you for joining us. Thank you for having me on, Jeran. It's always good to be here.
Indeed. And we've also got Alan, your opponent this evening. Alan, welcome to the show.
Hey, thanks for having me on, Jeran. Much appreciated. Toon, thanks for being here. Looking forward to getting into general relativity.
Yeah.
All right. Are we doing just general, or is it special? Tell us what the topic is, since I...
So the topic will be general relativity, on the correctness of general relativity, and it's put up by, it's kind of stitched together by three main proofs: the perihelion precession, the gravitational lensing effect, and what's the other one? Gravitational redshift. So the first one's kind of like a postdiction, so it's not really a good proof. So we're focusing primarily on the starlight displacement, so gravitational lensing, and gravitational redshift, meaning the frequency shift in light due to gravitational effects.
Okay, that works for me. And we're going to do a coin toss, and then you guys are starting with, 12 minutes?
Yeah.
Yep.
Okay. Let's do the coin toss. Let me get that on screen for you. Hopefully you can see it. Well, it's kind of shouldn't be see-through, but for some reason it is. See it up there? It's got the right now it's got the modern day debate logo on there. You can choose debatism X or modern day debate. Who wants to choose? Let's have Toon choose.
Which one is Tails?
Tails would be
Modern day debate, right?
Debatism X.
Oh, all right. I'll take Tails then.
Okay, here we go. He chooses debatism X, which is clearly the better show, and he wins. All right. Going first, going second. What do you want to do? Choice.
I'll go second.
Okay.
Nice.
And that means you're going to start out, Alan, and you're going to have 12 minutes, right?
Mm-hmm.
Okay.
Whenever you're ready, good sir.
Yep. And then do you want me to tell you when you have a minute left or so?
Yeah, just say 1 minute or whatever.
Okay.
In my ear.
Sounds good. And we're going to turn that off. Great. All right. Whenever you get started, I will start the clock.
All right, cool. So we'll go ahead and get into it now. So this is on the alleged experimental and observational proof of general relativity. So in 1905, Einstein released his first mixtape titled On the Electrodynamics of Moving Bodies, where he disses the ether in his first track, and then it goes on to explain that goes on to explain relative motion through a constant velocity, and he says that the speed of light is always the same for inertial observers. In 1915, he releases his first LP called The Field Equations of Gravitation, where he's extending his theory to a theory of gravitation and acceleration, linking the two with the equivalence principle. For acceptance of the theory, it must be able to explain the frequency shift in light and the displacement due to gravitational influences. So the principle of the equivalence principle states that an accelerated frame is equivalent to an inertial observer in a gravitational field. So, in other words, this means that an observer in a gravitational field would experience the same amount of length contraction and time dilation relative to the magnitude of the gravitational field or acceleration. So Einstein shows here that by taking partial derivatives from the spacetime metric g mu nu, that it reduces back to Newtonian approximations for objects moving at low velocities or when they have low mass. So this is extremely important because it extends Newtonian dynamics to the solar system, which gives physical meaning to the geometric expression of spacetime, sorry, which is said to be where Newtonian dynamics emerge from, right? So we're going to learn more about this theory so we can learn and understand the tests that are put forward to prove the theory. So here's the modern formalization of the field equations. Going from right to left, we have the stress mass energy tensor, and there we have the distribution of the gravitational field through space-time. And then on the left-hand side there, we have basically that just describes space-time curvature to be brief. And then the idea here is that we're going to conserve mass, energy, and momentum into a field that's distributed over space-time, which causes curvature. A manifold is a curved surface that can be treated as locally flat by adding a time axis perpendicular to the spatial axis or to the spatial x-axis in an XYZ coordinate system. Space-time is created, and again, just conserving mass and energy into the gravitational field causes the curvature. So the gravitational field causes hyperbolic curvature of the localized manifold, leading to space-time curvature. So this requires a new definition of orbital mechanics for objects in motion through the gravitational field. There'll be their orbital path is described by what's called a geodesic. A geodesic is defined by the shortest path between two points in space-time, accounting for a curvature. So in the third dimension, the geodesic will appear to be linear and straight, and in the fourth dimension, you would see that you're actually traveling around curvature. Gravitational fields bend space-time, causing celestial bodies to move along these curved paths in free fall. Gravitational effects, i.e. the illusion of mass attracting mass, is an emergent property of this space-time curvature within the localized manifold. Now, that all sounds very fantastical, but let's get an easier way to look at it, right? So we have a graph here with two observers. We have an inertial observer represented by T and X, right? And then we have T prime and X prime, and then we have an angle, or we have theta here in between them, right? So this represents the amount of divergence in time and distance between an observer who's in a gravitational field or experiencing acceleration relative to a stationary observer. So that's all that math describes. It's just a hyperbolic curvature between two different reference frames, right? So that's all cool abstract mathematics. How do we make it meaningful? How do we get it to apply, right? So we're going to go through some astronomical and lab experiments and observations that are put forward as the proof. So the perihelion precession, which is a postdiction, so not a good proof. And we have the deflection of light rays, which is a prediction based on the magnitude of the displacement, which is based on the magnitude of displacement, which will help distinguish relativity from the classical theory. And then we have gravitational redshift, which will mechanistically describe how light interacts with the gravitational field in the form of frequency shift, i.e. retardation in the frequency. So we'll be focusing on 2 and 3 primarily because the first one's not a good proof. Second, so to analyze the first proof, we have to know what an arc second is. So if you look at the distance between 1 and 2 degrees, you break that up into 60 sections. You have 60 seconds of arc. And if you break each minute of arc into 60 seconds, you have 60, you're just multiplying that. So you can break 1 degree of arc. You can break 1 degree into 1/3600th of a degree. So that's how the sky measurements work. So general relativity predicts that starlight will be displaced due to the presence of a gravitational body because traveling along a geodesic, which is a curved path, the gravitational field will curve space-time. It is stated that Einstein predicted that starlight will be displaced by 1.75 arc seconds, whereas the Newtonian prediction was that the starlight would be displaced in the gravitational field of the sun by 0.87 arc seconds. 1 second, gotta get some water here. All right. So additionally, without getting into the quantization of light, these two theories have different conceptualizations about how light behaves in a gravitational field. So for simplicity's sake, let's just say that the mass attracting mass theory makes a different prediction than the space-time theory. So here we have Einstein's derivation for the displacement. Here he says that the alpha is equal to 4km over c squared r, which is in big K, K is big G, M is the mass of the sun, C is the speed of light, and R is the radius of the sun. So it's just a ratio against the speed of light to give them their angle there. And so to test these observational wise, there was an eclipse coming up in 1919, May 29. So Arthur Eddington and his boy Cromlin set out to Sobral, Brazil, and the island of Principe off the west coast of Africa to take observations. All of Cromlin's data was unusable due to thermal expansion and contraction during the eclipse, so they threw all his data out. Two of Eddington's plates survived with poor star distribution, where only displacement was observed at the solar limb, so one solar radii. So he takes the photographic plates back to jolly old England, and they get together. The boys at the RAS and the RS can get together November 6th and have a meeting, and they say, okay, Eddington proved that this is a successful confirmation of Einstein's theory. But however, at the meeting, there was some objections raised, which we're going to get into and follow up on. So the transcripts from the meeting, a man named Dr. Silverstein chimes in, and he says, he's basically saying if there's starlight displacement, in accordance with the relativistic prediction, there must also be a redshift observed in accordance with the magnitude of the gravitational field to establish a cause and effect relationship. Because at the limb of the sun, there's already assumed to be a plasma, an electric field, a magnetic field, gas, different temperatures, pressures, etc. So the theory would have to compete with going through a different medium, like a refractive index change, essentially. So at that location, the results are ambiguous at best, and it can't be stated that this is proof of the theory. And at the time, there were two gentlemen, spectroheliograph operators, who were world renowned at that time, Charles St. John and John Evershade, who were tasked with making the redshift observations, and they actually took observations during the eclipse and found no redshift that corresponds with the interaction of a gravitational field for the starlight. So let's see, and we'll come back to this guy. So a guy named Edward Dowdy Jr. does his own derivation for starlight displacement, and we're going to see a familiar equation here. But basically, the only thing he changes is the story of the radius of the sun. So instead of it being a giant gas giant, he describes it as a plasma. He uses, instead of the radius for a giant gas plasma, he describes it as a Gaussian surface, so that he can simplify the electric field of it, so that he can calculate the plasma, right? So it's literally the same equation. So this is, again, competing with general relativity because the starlight displacement only occurs in the solar limb. The prediction, or the theory, predicts out to 8 solar radii. No one's ever seen starlight displacement past the solar limb. So here's a recap of Dowdy's derivation here. It's identical to Einstein's, pretty much, just change the letter there. Okay, so now we're going to get into redshift. So typically for astronomical observations, you look at starlight through a telescope. It gets split through a diffraction grating into a rainbow, which gets projected onto a plate. You analyze the plate, and look at the colors, and from there you're looking for a frequency shift, because that's going to change the color. So you're looking for more red or more blue or what have you, right? So if you get colors corresponding to that, then then it means your theory, people are more likely to believe the story that you're telling, right? So the history of gravitational redshift observations for general relativity is kind of a disaster for the astronomical side. It took like 20 or 30 years before anybody could even come to an agreement of a proper derivation and everything for redshift. So we're going to skip straight to the laboratory here. In 1960 to 1965, Pound-Rebka Snyder, using a specific energy frequency, emitted energy at the top of a tower, where the energy is going to go to the bottom of the tower, and they expected a gravitational redshift due to the potential at 75 feet versus at 0. So they used a Mossbauer detector, which just detects frequency, converts it into an electric signal. The detector was only set to accept a frequency of the expected shift when it starts at 75 feet, and then the potential reaching 0 at the bottom. So that frequency shift that would happen, it was only set to detect a frequency of that amount. They did get a successful detection. Well, in their paper, though, they state, and in the first paper, because they did 2 experiments, so they explicitly state that they can't make any, based on the detection method, they can't make any determinations between relativistic physics or classical physics, because they both actually make the same prediction for a frequency shift in that regard. Only the classical prediction is c plus or minus v is not equal to c, meaning that there's a velocity change and not just a frequency change, because in relativity, in the conceptualization of how light works, when the frequency changes, the wavelength inversely proportionally changes to compensate to maintain the same speed. So this experiment can't tell if the speed of light stayed the same, but the frequency was there. So they suggested that they should redo the experiment with atomic clocks at the top and bottom so that they could time it out and see if relativity holds true or if classical mechanics holds true. This experiment was never conducted, and these men were given the Nobel Prize shortly after. So the problem here, which I just elucidated on, was that it can't distinguish between C plus or minus V equaling C or not. So how do we remedy this? Well, we do vertical interferometry. Here's two gentlemen from YouTube that did vertical interferometer setups. They both measured two fringes, and then a third guy confirmed it named Chris Machado. Okay, thank you. Who confirmed the effect for the vertical interferometer reaching two fringes, right? So there is a displacement. Now, what this means is that the speed of light going up and down is not the same. And that's not a prediction of relativity. That's a falsification of the mechanism of how they say, one, how light works, and two, the interaction with the gravitational field. It's not it's not up to snuff, as they say. So here we have a video also of Ken Wheeler showing frequency shift with relative motion through a field. This is known as the Stark and Zeeman effect. When electromagnetic radiation goes through a magnetic or electric field, there's retardation in the frequency, which can change the wavelength. So you can actually watch Ken with a ferrocell and a magnet move the ferrocell over the magnet, and he changes the polarity of light there, and it'll shift from red to blue on the opposite sides when he's moving it over. So these effects are well known. There's other mechanisms to explain these frequency shifts. They're not mutually exclusive to relativity theory. And that's pretty much it. So we can wrap it up there.
All right, great. Time's up anyway. Tune, so now he asked you a 30-second question, correct?
Alan asked me a question, I think.
Yes.
Oh, okay. I asked you a question. Okay, cool. So let's go. Let me pull up my questions here. Okay, we'll start with question 1. How can it be said that the general theory gives mutually exclusive predictions for an amount of starlight displacement at the solar limb when using classical mechanics and the least action principle, as Edward Dowdy showed, you can make the same starlight displacement assuming a plasma medium at the solar limb of the sun?
A plasma medium at the solar limb of the sun would need to be substantiated, but also the shifting has been measured farther out than just at the solar limb of the sun.
How far out has it been measured out? Like, because it's like literally nothing. They even do radio interferometry with it, and it's like it's at the solar limb. There's nothing out past that.
Dude, I think you haven't read up enough. I'll cover it. That's in my presentation.
Okay.
So.
You're supposed
All right, well,
a minute and a half you're supposed to have for a response. You need that?
Well,
if he's got contrary evidence, he can do it in this presentation.
Yeah, it's been measured. Good. It's been measured farther out than that. But I would need to see the substantiation that that amount of plasma reaches that far out, and what's the actual radius that he's talking about there, Alan?
At the solar limb, bro. It's like literally not anything past one solar radii, essentially.
Yeah, I've seen his papers, and he's saying that the sun is 150 million kilometers away, and that it's whatever size it is at the limb. If your claim is that the sun is 150 million kilometers away, and that it is the size of whatever diameter of the sun say it is, then that okay, that's an interesting position, but I still need to see the substantiation that that there's that much matter at that in those positions.
Well, luckily for me, regarding the derivation, it's just a ratio that changes proportional to the radius. So the distance and size and all that, and the masses, those are just constants that are applied to it. So the angle derived would be the same. So it doesn't, the distance is irrelevant. He changed the entire makeup of the sun, and it's just about the radius. So it doesn't matter. It's not the way that you try to attribute that as proof of the distance of the sun to reify it. It doesn't apply.
Okay, we got now your 12-minute response.
Okay, so this was a little bit different than we did last time. So my response was going to be redshift. So I'm going to focus mostly on redshift. So give me a second here to pull it up.
All right.
All right. So, and then bear with me for a second here. So, okay. And I'm going to share my screen here.
Okay.
Jeran.
Yep. I see just you there for now.
There you go.
Okay.
Okay.
And I'll add us back on there. Just 1 second. But whenever you start, I'll start.
All right. So here is, I've got a list of different gravitational redshift experiments. Specifically, they're not generally like the Pound-Rebka style. So part of the gravitational redshift is that clocks will have a different rate when in a different gravitational field. And the relationship is actually pretty simple. I'll show you in a second here. So here is a lab-based test of gravitational redshift with a miniature clock network by Zhang and et al., including Shimon Kolowitz. So he has some Shimon does some good speeches if you're interested in looking at them. Anyway, so they measured a gravitational redshift in a difference of 1 centimeter vertically. And this is the formula here. You got delta F over F. So that's a change in frequency with respect to frequency equals G. That's the downward acceleration times delta H. That's the change in height over C squared. So that's the formula, the prediction according to general relativity. And so this is what they're testing in this particular experiment. So here is a diagram of what they did. So this vertically here, this on the left, you can see this is a total of 1 centimeter tall. And then they have these different, this is an optical lattice where they've trapped strontium atoms and they've cooled them down so that each of the electrons are at their base state. And then they excite them. And so what it's doing is measuring the excitation between the base state of the electron and the one state up. So that's the shell of the electron, and it emits a photon then when it drops back down. So that establishes the clock. And they have multiple ones because they're always getting the atoms in and out of that state. So they do have a really nice error budget. So they go over the details of the error budget here so that they don't have anything that's going outside of their results. So they're sitting down near 0 Kelvin, and they're measuring the difference in the clocks at these different elevations in gravity here and comparing to the prediction. So the data analysis, I'll just jump down to the conclusion here is right here. So they measured the local gravitational acceleration, 9.803 meters per second squared, and the final frequency gradient here is there fully consistent with the expectation redshift gradient within 1 sigma total uncertainty. So this was much later than Pound-Rebka in 1960. So that's one. Oh, the nice part about this is a nice one. It was blinded. So what they did is oh no, where do they say that? All right, it's a blinded test. So what they did is the experimenters, people outside other than the experimenters, added some randomized data to the results, so that as the experimenters were manipulating the data, they had no idea whether or not it matched or didn't match the expectation of general relativity. And then only when they were all done with all of their computation and all of their work was the data unmasked, so that the randomized data then was subtracted back out of it so that they could get the final results. And Shimon talks about that in one of his speeches there, and how it was it kept them honest because they couldn't fudge anything. They didn't know until after everything was done what was going on and what to expect. So that's the most recent one, just in August 2023. But there's no shortage of them. Here's another one: resolving the gravitational redshift across millimeter scale atomic sample. Atomic clock performance in enabling geodesy below the centimeter level. So all these are much better than what Pound-Rebka was doing, where they were sitting, multiple stories of a building apart. One more on this: the apparatus is inside of a metal chamber. It is a Faraday cage, so it's one of the things that are well controlled in there. They also controlled for temperature. They discovered in their work that the viewing window modified the temperature, so they had to put in additional controls to keep the temperature consistent so that the proximity to the viewing window was neutralized. So, all right. How much time do I have left?
6 minutes, 45 seconds.
6 minutes. All
You
right.
see on the screen?
Oh, no, I don't. You're not sharing to me. I to Zoom. There, I can see it now. All right. Well,
There you go.
there it is. Okay, thanks. So let me pull up, you were asking about VLBI, and I don't want to spoil everything for my second presentation here. So I'll jump to, there we go. I'll jump to this one here. So this is an optical measurement of the Deflection by Donald Bruns in 2017 at the Eclipse in 2017. He did this in Wyoming, and now we've got a picture of him right here sitting at his table. And so he did a ton of controls, more controls than any of the other types of experiments of this nature. They stopped doing them in 1973 because radio measurements were significantly more precise. So his final measurement is 1.752 arc seconds. And I'll get into a little more detail on what that means in the next presentation. But the prediction is 1.751 arc seconds. So his uncertainty was only 3%. So he has greatly improved on other optical measurements. And I messaged him. He had a group of about 12 different researchers in different groups that were working on this at different spots for the last eclipse here a week and a half ago, or it's about 2 weeks ago. And let me show you his, so this is some of the actual data. This just in a PDF, so it's not high resolution, but this is the data that he got of the photographs. He part of the procedure was that after the photos were taken with the telescope, he put a cover over the end of the telescope and took several photos. Let me see here where we get the telescope again. Took several photos to determine the pixel by pixel light sensitivity, and then took several photos with a LED cover over it, so it was completely saturated, again, to get the total dynamic range of the pixels, to get a baseline for them. He also, before the eclipse, he moved the telescope 7.4 degrees to the left and 7.4 degrees to the right. Then after the eclipse, there it is. To control for the shape of the wavefront due to the lens coming through the telescope, compared to the shape of the imaging CCD, which is flat. The light coming from the lens is a paraboloid shape, and the lens is flat. So normally we don't see things like that with our own eyes, but when you're doing this type of fine measurement, you want to control for that. So it's one of the things he controlled for, and that gave him a linear and quadratic parameterization of the actual positions of the pixels as they relate to the sky. So, and to make it real clear, he used the Hipparcos data, which is accurate to 0.002 arc seconds or milli arc second precision for where stars are actually located. So he's able to get much better precision in that than like Eddington and the other eclipse expeditions were up until 1973, because they had to get plates either at 6 months later or 3 months later of the same stars, or there were different methods that they'd use to do something similar so that they could measure the positions of the stars, where we now have Hipparcos data that's millimeter arc second accurate. So all right, how we doing?
15.
Minute 15. All right. Well, I'm going to do, I'm going to ask Alan. Okay, can I jump ahead to that, please?
You can.
All right. Alan, what is Einstein's cross? How do you explain Einstein's cross?
Talking about an Einstein ring?
Einstein's cross is a specific instance of it. There's four different.
Has anyone ever seen one with their own observations? Or is it just data that you get from, the deep space network? Because if no one's put their eyes to a telescope and seen an Einstein cross, I don't know. Because apparently you can do, Dowdy showed calculations where, due to gravitational influences and whatnot, the whole sky should look like, Einstein rings and mini Einstein rings and whatnot. So when you say that, what are we talking here? Are we talking DSN, or are we talking opticals with the eyes? Can you hear me?
I wasn't interrupting you. I just.
Oh, sorry. Yeah, I'm putting it back to you. What are we talking?
All right. So you don't have a response. Okay.
Can you hear me?
I can.
We heard you.
Yeah.
Yeah. So have you seen an Einstein ring with your eyes, or is it just from images from the deep space network, from satellites looking out into space?
I don't know. That's not an answer to the question, though.
You said, how do you explain it? And is it even real? Do I need to explain something that no one's seen? Is my question.
If that's your standard of evidence, then you're going to have a hard time with any evidence that you bring.
Right?
Okay,
dude. Are you able to substantiate the Einstein ring or no? Is it just something you believe exists and you want me to explain it? Because the deflection derivation comes from the same one that predicts the Einstein ring that no one has ever seen. So that's my answer. And if you don't have an answer for that, then, I guess touche.
All right.
Okay. That's his minute and a half response as well. So then we're supposed to have a 12-minute exchange.
All right. 12-minute exchange. Oh, sorry.
Yeah. Okay.
Unless you have more comments.
Cool.
In a minute or so.
Did you have any other comments, questions?
Do you want to tell us what an Einstein ring is?
Yeah, there's one in particular that is that you see four different copies of the same object behind something that's been gravitationally lensed.
Oh, so yeah, definitely only from the deep space network. All right. So let's see. So we put forward some atomic clock measurements, right? And you were saying that this is different from the Mossbauer detection, but actually that's not true here. So let's take a look at the inner workings of an atomic clock. To be brief here, we're taking cesium, sending it as a coherent beam through collimators to a magnetic field into a resonance chamber where they're shooting radio waves at it at a specific frequency to match the resonance of the cesium gas, and then it leaves the magnetic field, gets ionized and converted into an electric signal, which they then read that energy as the whatever like pulse that makes. They're like, okay, that's one what is it, 9,192 millionths of a second or whatever. So like that's how they break it down. So that's actually the exact kind of same mechanism as the Mossbauer detector. It's just converting the energy into an electric signal, which they do to take their readings. So as I pointed out, though, that the speed of light's actually changing with the vertical interferometry, as noted by the fringe displacement. So the mechanism of like, oh, this is due to the gravitational field of Einstein stuff, not even on the table with that. So all the atomic clocks are just this, like literally the same, suffer from the same issue.
But
They're
Alan,
not able to make a distinction.
Did you see this with your own eyes?
What's that?
That's your standard.
No, that's how they work, brother.
No, that's your standard of evidence. You don't allow anything that you didn't see or somebody didn't see with their own eyes, right? If they didn't see it with their own eyes, it doesn't exist.
Yeah.
Right?
Cool.
That's your standard, Alan. I want to make it really clear. This
that's
is
the way
your
you wanna
requirement.
take it.
No. This is your
No.
requirement. You hand wave dismiss things that you don't like because you didn't see it with your own eyes. Then you're going to bring up other things that you did not see with your own eyes, that nobody saw with their own eyes.
Okay. Well,
That's your standard. You need to be consistent, Alan.
hey, moderator, please. I'm about to talk.
Yep.
All right.
What do you guys
So
want?
this,
Go ahead.
I got you, bro. So the standard for evidence, right? You're talking about an optical observation to confirm the bending of starlight that no one's ever seen, right? This is an atomic clock with mechanical parts that can be measured that does specific things and functions a specific way. It's very clear how this works. There's a diagram. You can look at it. You can figure out how it works. It's not a mystery here. I'm not making a giant leap of logic. These redshift detections do not go your favor. Interferometry shows that the speed of light is actually changing vertically. So the application of, oh, this is due to the gravitational potential of the Einstein field, not on the table again, sir. And you're not going to get me with, oh, your standard for evidence is different when you're bringing up a phenomenon that no one's ever seen outside of a computer, when we have actual technology here on the ground that we could look at. Do you have a response?
Yeah. People have seen it. People have done it. And you're hand wave dismissing it because you don't like it. That doesn't work that way.
Show me their pictures that aren't from the Deep Space Network.
I don't need to. Deep Space Network is perfectly fine.
All right, bet. All right,
There's nothing wrong. There's nothing wrong with that evidence unless you actually show the error in the evidence, Alan. If it's wrong, show us wrong. But just, I don't like it, therefore I'm going to not respond to it, is just waving a white flag.
It's not that I don't like it, right? The prediction of the bending and all that comes with specific requirements involving the gravitational field, right? On the ground, in the lab, what we can measure, what we can confirm, doesn't show the same relationship that would be applied to the sky. So if someone's sending you images from a deep space network that no one's ever seen with their own eyes, and it says, oh, it matches this formula that doesn't even represent the behavior of light in reality in the lab, then what are we doing here, bro? That's the distinguishment here. It's not that I don't like it. It's that there's prerequisites for believing it that aren't substantiated in the lab.
Okay, yeah. So it didn't solve any problems, though, Alan. You just don't like it, and you just ignore it. So I will apply that standard to you. So any evidence that you bring, you need to make sure that you have the ability to look at yourself. Okay, that's fair.
Are you denying the functionality of an atomic clock, just for the record?
No. I'm saying that you're not allowed to bring up an atomic clock because it doesn't match your standard of evidence. Because you aren't seeing the atoms moving through there, and you aren't seeing them get counted, and you aren't counting them, right? A computer's doing it. It's through some abstraction that you didn't have control over and your eyes didn't see. So you don't get to use it for your own reference. You only get to use things that are consistent with your standard.
Dude, did
Bet you. Hold on a second. Hold on, Jeran. No. I don't care. Watch me use it. Okay, so you believe in little counting particle atoms. That's not even what's happening, dog. They're converting a frequency. They're ionizing it, so it's just energy, and then they're turning that into an electric signal. That's not counting atoms, dog. This whole model of how this atomic clock works based off of the valence electron and all this stuff, completely irrelevant, dog. All that's happening in here is that there's
What's
gas
a frequency?
Huh?
What's a frequency?
It's vibration per second.
It's a photon, Alan.
No, that's a
There's
conceptualization.
a photon
Okay.
emitted when the electron changes state, right?
No, that's the
Yes,
quantum
that's
model.
what's happening. That's what's happening.
That's the model of the photon, right? Which is reified by the Compton effect.
Yeah,
which
but none of that exists to you because you didn't see it with your own eyes.
Okay. Well, 1 second, dog. If you're going to invoke the photon, right? So at the beginning of this debate, I said that we're going to skip over the photon because it's a complex subject, right? But if you want to get into it real quick, we can do that, okay? So you're arguing that, oh, it's the quantization of light. There's a little particle and all this, okay? That comes from applying Planck's constant to the frequency, right? So just multiplying the hypothetical amount of energy that can exist in a second as the quantization of the part, right?
No,
this is
no. It's not
E equals HV, dog.
Yes.
It's literally that.
It's
So anyway, I'm going
nu.
to continue now.
Yeah.
Thank you.
Good.
So or H mu, right? So anyway,
nu.
yes. So what
Yeah.
they're doing there is that they're just multiplying the quantization of the black body radiation from Planck's constant, right? They're saying that this is there's a proportionality ratio with the particles, right? Now, this is reified entirely, not from the double slit experiment, not from the quantum eraser experiment, not from the which way experiment, but from Compton scattering, right? We're told that this is a mutually exclusive proof of the photon, and this like really settled the deal. And this is the backbone of particle physics and quantum mechanics. Now, again, you're never going to believe what suffers from the same issue with the Compton scattering prediction for the wavelength change. They're doing an energy frequency conversion through ionization to measure the energy and assuming that the output is proportional to a wavelength change that they need to reify their model. And then while they're analyzing it through relativity, they go, okay, well, we have this stationary electron that doesn't move, so it has no kinetic energy. And then they go, okay, this photon hit it. Now there's a billiard ball collision. And because there's no kinetic energy, blah, blah, blah. It's based off of all these assumptions to reify the model. I don't subscribe to that version of the photon, nor do I need to talk about the measurements that are made with the atomic clock, dog.
Yeah, well, I was just pointing out that you're not using your own standard of evidence here, but that's fine to be inconsistent. But the point of all of this is that they are accurate in their measurements.
Well, agreed. But the problem is there's no this measurement doesn't tell you if there's little tiny balls colliding or anything about the constancy of the speed of light.
Of course, that's beside the point of the gravitational redshift.
The point, because you're saying that I can't use it unless I can see all these little tiny balls.
You're saying that you can't use it. I'm just holding you to your standard.
No, you're saying you can't use it because you're saying I can't use it because I said that
because your standard of evidence doesn't allow you to use it.
You're invoking something where the measurements don't align in the lab.
Alan, I'm just saying that you can't use things that don't meet your standard of evidence. It's hypocrisy. Don't you see that, Alan? You reject things that came from a computer measuring things when they don't agree with you, but you will accept things when it's a computer measuring things when they do agree with you. That's inconsistent.
When it's a real technology that you can use right? The explanation of how it works, I don't agree with, right? But it does function that way, and it doesn't tell you anything about the constancy of the speed of light, which is required for your gravitational proof. That's the whole purpose of it. That's why, yes. Why would the gentleman from Pound-Rebka say, "Hey guys, we're going to need to do this with an atomic clock because we actually can't tell with our frequency detectors."
And then they turn around. Then people have done it with an atomic clock, Alan.
It's the
many times.
That's it, brother. Do you understand the conversion of how they're making the measurement? It's this. They suffers from the same issue. Do you get that?
Did they measure a difference in the clock?
Yes.
Okay. What caused the difference in the measurement?
Did they measure a frequency shift or a velocity shift, though?
Frequency.
What caused the frequency to shift, though? Was it velocity or was it
gravitation?
Potential? How do you know? Ta-da!
Yeah. And how do you know that it was frequency or velocity?
Interferometry.
Where?
The fringes wouldn't be produced if
There's no fringes in these.
If they were in phase.
There aren't fringes in these.
The evidence that I invoked. Right? Remember how we came with our own evidences? And I came with vertical interferometry that showed a fringe pattern, 3 separate people confirming it. One of the dudes was a guy that was against it, right?
Well,
he made his device.
Right,
hold on a second. Hold on, dog. One of these guys, he was like, this isn't real. This is a mistake. Instrumental error, blah, blah, blah. He does 2 iterations of the experiment after making improvements on it, measures the same thing twice, dog. So we have variance in the speed of light vertically, hands down. So my evidence supersedes yours. Yours is a frequency shift that can't determine anything about relativity or classical physics. I have the actual determination factor here, buddy.
All right, that doesn't at all apply to the specific one that I brought up.
Yes, it does. Does what you brought up involve electromagnetic radiation? Yes.
Yeah.
Right. So
they're
applies.
measuring. Yeah, they're measuring the base state between electrons and strontium atoms.
Yeah. Well, luckily we could measure the propagation rate of that too to see if it's going faster in one direction than the other, and it shows through interferometry that it does.
Alan, how can the speed of light vary when the number of photons is what they're counting?
They're not counting the number of photons. It's an energy conversion based off of frequency, right? So they're not counting photons. You have a gross misunderstanding if you think an atomic clock is counting little billiard balls.
Photons aren't billiard balls.
Well, the conceptualization of them would have to be, right? Because you're counting a little something that's not nothing, right? So what are they counting?
They're not. They're not. That's not the idea of what electrons are, or what photons are.
Well, we already went over that,
billiard balls.
but like I said, we're doing the simplification of it. Okay, so the nothing hits the photon, or sorry, hits the
It's
electron.
not nothing hitting it.
Listen, guy, you're the one. It's just a joke, man, because you're like, it's not a billiard ball, but it does an elastic collision involving a little tiny sphere. I don't know. If you want to call it not a ball, that's fine, and get into the semantics of it. You're the one that believes in the quantization of light, not me.
All right.
Okay. Time. And then we go to another topic. Is that right?
Yeah, I think I present.
You went. Yeah, you can. You won the toss. So he went first last time. Now you're going to go first this time.
Yep.
Gotcha. Okay.
All
So
right.
you got 12 minutes when you're ready.
All right, I'm going to share just a second.
Whenever you get started.
All right, you got that there?
And you're sharing screen?
Yep.
Okay. Whenever you start.
All right. So I'm talking about light deflection or gravitational lensing. The Alan went over this pretty well. The hypothesis from Newtonian with the mass energy equivalence is that light passing near gravitational wells will deflect. And the general relativity hypothesis is that light passing near large gravitational wells will deflect twice the Newtonian amount. And of course, the null hypothesis is no deflection, or, different people have had different interpretations over time. So this is a diagram, not to scale, of what is going on here. So we've got the Earth there on the top right. You've got the source and the sun. So the source is the light is going from the source to the Earth. And the bending, there's no bending in this diagram, but the bending will cause the light to appear to be from the reference source. I use this one because it's got the variables listed on there. So it's important here to look at. This is a little bit of math in this one here. We got delta theta on the bottom there. That's the change in the apparent location. Is 1/2 of 1 plus gamma. So that 1 is the Newtonian deflection. If you remember from the previous one, the hypothesis for Newtonian is a particular amount of deflection. That's the 1. And then we've got the gamma, which is the curved space-time deflection. So you got 1 plus gamma. Gamma in this instance, if general relativity is correct, then it's 1 as well. So you've got 1 plus 1 is 2. So you got 1/2 of 2, which is 1. So when you multiply that by everything else, you get nothing. It doesn't change, not nothing. It doesn't change it. It multiplies out to be just 1. You've got 4 times g times m, the mass of the sun, over c squared d. That is on the right. We've got the little key there. The important part then is also 1 plus cosine of phi, and phi is the angle between the sun and the path of light that it took, over 2, right? Now, when for the limb of the sun, so a grazing ray that comes right next to the sun, phi is 0. So the angle between the sun and that light there in that from the source on the bottom left of that diagram to Earth on the bottom right diagram, that the distance between the sun and that ray is phi is 0. Cosine of 0 is 1. So that total right term is 1 plus 1 over 2. Again, you get 1, leaving all in the middle there 4 gm over c squared d. And we'll see that in the next one here. But the prediction according to general relativity is 1.7505 arc seconds at the limb of the sun. So here's the two predictions, the Newtonian prediction and the Einstein or general relativity prediction there. We've got theta equals 4 gm over c squared r, and that's the same one here in the top. 4 gm over c squared d. D and r, different variables, different papers reference them differently. Anyway, so that's the hypothesis on the edge of the sun. Here is the graph of what they would look like in relation to the distance that they are from the edge of the sun. On the left vertical axis is the deflection in arc seconds, and on the right is the solar radii. So at 1 solar radii away, you've got a deflection of 1.7 in that red and 0.8 in the blue, and then the horizontal axis of 0, that's the null where there's nothing predicted. So there's a null. All right, so the Eddington plate, yep, there are plenty of issues with that, and fortunately people have done better experimentation since then. So again, here is the one from Don Bruns, where he controlled for confounding variables very precisely. This you see that paraboloid there in that diagram? That is the light, the wavefront of the light as it passes from the lens to the plate of the sensor. It's out of scale, but he's using the positions of different stars to measure how much that modifies it, and then quantify that so that he knows exactly how much it's deflecting that, so we can do that. Get some precision. The important thing about this is that he did in 2017 using consumer level equipment. You can do this yourself. In the past, it was stuff that people, it was difficult to do because you had to have some pretty big equipment, but now you can do it yourself. These again are some of the pictures he took. And here is the chart of the displacements that he took. You can see the black line, I believe. I'm colorblind, but I think the black line is the Einstein prediction. The grayish line there is the Newtonian one. Of course, the horizontal axis is the null prediction, and these are the positions of the stars. Now you can see how far out he measured them. This went almost to 5 radii out in his, and his results were within 3% margin of error. Here's his conclusion, an uncertainty of only 3%. So that's the most recent optical measurement, but there have been radio interferometry measurements since then. In 1976, Erwin Shapiro figured out, it was 1960, forgot the years, 1967? I think I wrote it down wrong. Erwin Shapiro figured out a precise method using radio telescope interferometry with multiple telescopes that are a distance apart. The farther apart they are, the more precise they are. It's called VLBI, or very long baseline interferometry. So if you see VLBI, that's what it is. This is a chart of the different measurements of light deflection over time. That bar across the middle there, 1.0, that's gamma equal 1.0. That's the prediction of general relativity. And so you see at the 1973 expedition to Australia, the final eclipse, one put on by a large organization. And you see those error bars, they're rather large. And then in 1974, the radio interferometry from 2 quasars is significantly closer, and the error bars are much tighter. And since then, there have been several others, much more precise measurements. So here is the specific one from 1974. Shapiro was involved himself. He's one of the authors on the paper. They used the 120-foot Haystack radio telescope and the 60-foot telescope in Westford, Massachusetts. They also used 2 85-foot telescopes at the in Green Bank, West Virginia. And here we see after their they did a they tracked two quasars as one of them passed into the sun, and they were about 10 degrees apart, and they were constantly measuring the deflection between them, and they started quite a few degrees out, not much more than, or they were more than 8 solar radii out. I think they were 15 degrees out from the sun in this particular one. So again, their results are gamma equals 0.98 plus or minus 0.06. That tracks with relativity. And again, you see that gamma is the Eddington, I didn't mention Eddington-Robertson parameter, or general relativity, equals 1. And that's the equation again. I'm reminding you of the equation because that's what they're always testing here with this gamma stuff. Since then, there have been more. This is from 2004. This is a different Shapiro, SS Shapiro, not II Shapiro. Maybe they're related. So the experiment used 87 VLBI sites, 541 radio sources, yielding a total of more than 1.7 million ionosphere corrected group delay measurements. So 1.7 million measurements. So where Eddington had 7 and Don Bruns had, I think, 17, they had, this is 1.7 million different measurements into this study. Here is the positions all over the Earth of where these radio interferometer radio telescopes were located. And this right here, Alan, is the one I was talking about. You can see here the distribution of the positions of the measurements in relation to how far away they are from the sun. And even at 175 degrees away from the sun, the amount of deflection due to the gravity of the sun is two-digit milliarcseconds, I believe. And the precision is significantly more than that in this type of measurement. So they're well within their ability to measure even 175 degrees away from the sun. So this big arc of measurements in the middle is not the actual measurements, it's the number of measurements that they did in relation to how far away those measurements are from the sun. So 1.7 million measurements right there in that graph. And that power graph there, on the top left there, you see that? Arcing down toward the bottom right. That is the Einsteinian prediction, gamma equals 1. That's what that line means, is gamma equals 1. So what were their results? They got 0.9998 plus or minus 0.0004 of gamma. So gamma equals that. It's predicted to equal 1. So they're within, that's 4 times smaller than any previous measurement of gravitational deflection. And again, I put that, the equation on the screen there again. Gamma is the Eddington-Robertson parameter of general relativity. If general relativity is right, it equals 1. They found it to be 9.9998 plus or minus 0.004. So 1 is within their error bars, and it's very, very precise. And they did definitely get farther away than any plasma corona of the sun to that.
1 minute.
So anyway, in conclusion, we got multiple different lines of evidence. I didn't cover other ones, but there are other measurements as well than just radio interferometry. They've used quite a few different techniques, including Shapiro delay. It's a different way. It doesn't need 2 telescopes as much. Using varied methods, they've measured deflection. These confirmed a high precision that light deflects into a gravitational field, the amount predicted by general relativity. So, there you go.
Okay, I believe you are supposed to ask him a question now.
Yes. I don't know. I don't have a question for you, Alan.
I got you, Brody. So I'll throw you a bone. So I'm not disputing the phenomenon of displacement. I'm disputing the causal mechanism, to be clear. As when shown in the lab, the gravitational field, which is assumed to be the causal mechanism, doesn't seem to hold true, nor does the interpretation of light, being that it maintains a constant speed, which is required for the interpretation. And then we have, let's see. So see again, so this is the equation though, it's still just a ratio. So it's not telling you anything different than the plasma lab. They're still making the exact same prediction. So when you get to the displacement outside of the solar limb, like again, that is interesting, but with the causal mechanism is in dispute. And what I would like to turn it around to you is I would like to point back to what Silverstein said at the November 6th meeting at the Royal Astronomical Society regarding the eclipse, where he says if there's no substantiation of the redshift to match the displacement, we can't attribute this phenomenon to Einstein's laws of gravity, because if there's no curvature from the gravitational field, then that's not, that's not the causal mechanism, and the theory can't explain anything because geodesic paths would just be straight lines with no curvature to travel along. So do you have anything to say?
All you did was deflect to a different topic. Let's stick with this topic.
Well, your topic requires a causal mechanism, which again, I'm not disputing happens, but it's the causal mechanism associated with it, right? Because there's like not trial and error. Like when you're doing science, you're establishing a cause and an effect, right? So we see a phenomenon. Oh, there's a starlight displacement at a proportional ratio regarding the speed of light and the radius, and these are constants that we apply to it. So it's like, what does that? Is it a gravitational field or is it something else? How do we know? Well, we can test in the lab the concept of the gravitational field through the frequency readings like we did earlier, right? And through interferometry. So we can determine how light's functioning here on Earth in the expected gravitational field to see if that would be applicable to the sky. And it turns out it is not.
You didn't address the topic at all, Alan. You still didn't.
The phenomenon
you said
causal mechanism.
No,
they're hand in hand, bro.
Your guy that you brought up, what was his name?
Mm-hmm.
Dowdy. You said it's in the limb. For the audience, what is the solar limb?
The solar limb is just at the edge of the sun, where space meets the sun, essentially,
Yeah, okay.
right? Where that light stops.
So you said that when you talked about it, you said that they've never measured deflection outside the limb.
Mm-hmm. I wasn't aware of the other ones that you brought forward.
Okay. So now I showed you measurements outside the limb.
Yes. And the predictions are still in alignment with the same ratio, but there's supposed to be a causal mechanism established with it, right?
You're claiming that it's refraction in the atmosphere of the sun. That's what Dowdy was talking about, right?
Well, I'm not specifically claiming that, but what I'm claiming is that using that ratio, you can come up with different stories about why it's displacing.
Okay, and let's hear them. Let's have the empirical evidence supporting them. So far, it's just an appeal to possibility.
Well, that's what the theory of gravitation is, right? It could be it could be space-time curvature, or it could be some other mechanism, right? Because if it's
you're proposing something else. Let's have it. What is that other else? And where's the empirical evidence for the other else thing you're talking about?
How do we determine which one is which, right? We do the lab experiments.
Alan, there is no sun atmosphere 175 degrees away from the sun. So your Dowdy reference doesn't apply. So I'm asking, why is the light deflected the amount it's deflected, and you don't have anything? Dowdy doesn't apply.
Dowdy's thing still applies. His equation doesn't stop at one solar radii.
He said that it is happening because of refraction in the sun's atmosphere. There is no sun's atmosphere 175 degrees away from the sun.
Listen, dog. His equations make the same predictions. Your equation, to substantiate it, to be associated with
a plausible mechanism.
Don't interrupt me when I'm talking. So to substantiate your theory as the causal mechanism, right? There has to be an associated amount of frequency shift, right? The light has to be retarded proportional to the magnitude of the gravitational field. Do you understand that?
Yes, and it has been empirically confirmed.
Okay. It actually hasn't, though, because as we just went over the history of it all, it's all based off of converting a frequency of energy into electric signals, which doesn't tell you anything about the wavelength or anything about the speed in which the light was traveling, right? So to falsify that, you would do it with interferometry.
To falsify it, you would need a measurement of that light then, since you think it's light's speed that's changing instead of the frequency that's changing.
It's
right.
Do you not know how
an
interferometer works?
I do.
That's exactly
but
what
this
it
isn't
measures.
an interferometer.
It doesn't matter, dog. It's electromagnetic radiation.
It does matter. You're talking about an interferometer when we're not using an interferometer to measure it.
What's the speed of electromagnetic radiation?
What's the speed? It's the speed of
Yeah.
light in that medium.
Okay. What does an interferometer measure?
It measures, it doesn't measure the speed of light.
What produces the fringe pattern that's proportional to the velocity that it's measuring? It's a variance in the...
It's a displacement.
Based off of
and
what?
many things
What
can cause
causes
a
it?
displacement. A difference in the path can cause a displacement.
You say many things
A
can
difference
cause a displacement.
a difference in the length of the path can cause a displacement.
And what causes that? Is it a proportional relationship?
Movement can cause it.
Is it a proportional relationship with the velocity? Yes. So the measurement shows that in order for there to be a fringe, that the speed of light has to change. Now, the path length in reality doesn't actually change, nor does the time.
Of course, the path length changes.
Hold on 1 second. Don't interrupt.
When it's
'cause you
moving.
Listen, dog. Conceptually, right? You can make a prediction in the lab frame using the formula for the displacement based on the velocity of the rotation of a table, right? And then that plays out on the rotating table. The time and distances are exactly the same, and the ratio of the speed of light is produced.
But they're not
right?
the same, Alan.
No,
The distance is not the same. While the light is moving, the table is also moving, and the path changes in length from when it's emitted until when it's read.
So number one, you're invoking absolute space to change the distance of the table for, yes, you are, for invoking or for electromagnetic propagation. Now, if you do that, right, to maintain the speed
Alan,
of light,
I'm not.
yes, you are.
Don't tell me I am. I'm not.
I'm
The
about to explain.
The path changes
I'm about
length.
to explain how you are. Please don't interrupt. So this is how you're doing it, right? If the speed of light is the same and it's the table that's causing the actual displacement, then there would be no fringe pattern. It would recombine and not produce a phase shift.
I disagree completely.
You can disagree completely.
I completely disagree, and I'm 100% not the fringe person here, Alan. While the light is moving from the emitter to the receiver, the path can change in distance depending on the movement of the apparatus.
Conceptually, if you invoke absolute space, sure.
No, you don't need absolute space to do that.
100% you do. That's the whole point of Einstein's theory.
No, there's no absolute space in this at all. There's an emitter. There's a receiver. There's a path that the light takes. And if the light takes a different path, one direction and the other direction, and the length of that path changes, we don't need any absolute space to do that. They're all relative to each other.
If the speed of light is the same, it won't recombine and produce a fringe though, right? So that's a problem. So anyway, we can move on from that though, because
you don't like that? All right.
No, I mean, we can stay on interferometry. The purpose of it was to be more in talking of frequency shift and stuff, but I guess we can't really move on from it because it's the crux of the two differences. So if you want to get into how interferometry works and the exact mistake you're making, we'll look at this right here. So this is...
You have your 12-minute response still to go, right?
Perfect. Oh, do I? No. Okay, great. We're about to learn about interferometry. Give me 1 second.
Do you have any final comments on that one, or?
I guess we will shift topics then. All right.
Well, we did your 12 minutes, and then you didn't have a question for him.
Yeah.
So we were kind of just in la la land.
Yeah.
All right. So now you got your 12 minutes. Go right ahead.
1 second. All right. So this is, let's see, 2022. So a recent one. Now there was one in 2015, but this is the modern one. So exactly how Toon was describing or misdescribing how an interferometer works in regards to absolute space and the time being different due to the rotation of the apparatus. That's actually not true. That absolutely would not produce a fringe. And I highly recommend everyone that thinks it would produce a fringe, read this paper by Barreda and others, 2022, who's going over the Sagnac effect and how it's difficult to explain through relativity, because if you would do what Toon's doing there, saying, well, the distance is changing because it's rotating, that's invoking absolute space. It cannot produce a fringe. This entire paper is about, hey, we can explain this without using a Lorentz transformation, but they can't. It can't be done. It's literally V over C. There's a ratio relationship with the velocity. That's what produces the fringe. And it's proportional to velocity because the wavelengths are not combined at the same time. If the distance was actually changing and c was the same, there would be no fringe measurement. It would recombine with no fringe. So that's not even on the table, right? Now, that's really all I needed for that. Okay, well, real quick, we'll go to Einstein. We'll see what Einstein has to say about absolute space and this exact problem right here. So here we have Einstein, oops, it's the wrong year. Where's my 1905 Einstein? 1 second, lads. On the electrodynamics, moving bodies. That's weird. Shoot. Okay, well, anyway, Einstein says in his 1905 paper in the first 2 pages, right, he says we don't need an ether, so we don't need to invoke absolute space, and we don't need to describe or ascribe imaginary vectors for electromagnetic propagation where none such exist. And what Toon's doing there by just changing the distance of it, he's invoking electromagnetic propagation in imaginary vectors where it doesn't exist, right, to maintain the constancy. So Einstein's like, we don't need that. We can explain it without it. So this is an explicit violation. Later in the paper, he goes on to say that his equations hold true in any uniformly rotating polygonal circuit. So if there's a closed light beam in uniform rotation, now they say, okay, that's an acceleration because it's rotating. Any point from it will be infinitesimally, accelerating that are different from the last, blah, 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 right? But what the actual implication is, right, is if you take a closed polygonal circuit and extend it to infinity, it doesn't really deviate from linear motion, right? So it's identical. So he's saying that his equations will hold true in that frame. So when you apply a rotating interferometer, the speed of light should not produce a fringe, and it does. This is why Sagnac said in 1913, when he released his mixtape called Ether, that he falsified relativity theory. All right. So I think that's all we need to do to cover the conceptualization of light. Okay, yeah, one more thing. So in relativity theory, they say that there's no frequency shift that there's no change speed in light. There's no velocity change. It's a fixed velocity, and that when there's a frequency change, right, when there's retardation, light's not slowing. Well, it's the frequency's slowing, but the wavelength is extending inversely proportional to the frequency shift to maintain a constant speed. But that's actually not what's happening, and we can show that through interferometry. So when we look at the atomic clock, the humble atomic clock who's converting signals into electric or converting energy into electric signals, that's not telling us anything about the causal mechanism of the shift or the behavior of light in a meaningful way that can be substantiated, that would be required for general relativity to be proof. And here we go. I got a little screenshot to pull up here. So here's from Einstein's paper here. And I already covered it, so we don't need to reread it, but it just says light is always propagated in empty space with a definite velocity. It's c, it is independent of the state of motion. Now, obviously, we're talking about a place where there's a medium. You can account for that in the equations. It's not the concern here. The main priority is that the speed of light is supposed to be the same. And if it's not, and if it's producing fringe shift patterns proportional to velocity, then there's something else going on, because when you do the equation V over C, you're referencing light in its inertial reference frame, which is absolute space. Good game, lads.
Okay, Toon, you got a 1.5-minute response.
A 1.5-minute response?
You can respond as long as you like.
Yeah. The question and answer part of it, I think, was a little... We kind of misinterpreted having that in there still. Maybe we just go to the open.
Yeah.
What do you think?
Okay, we can go to the 12-minute convo.
Okay.
Yeah, absolutely.
All right. Well,
try to let each other finish if you could, please.
Yep. All right. Oh, hold on. I gotta fix this.
Okay, these are good. I'll set the clock for 12.
All right. So here you go. Here is interferometer. You got light comes in, splits, goes 2 directions, it's a little simplified. It'd go around a few more times potentially. But it comes out, and if it's stationary, then the path here and the path here, same length. Here you go. A moving, rotating interferometer. Light comes in here. While the light is moving through the interferometer moves, and then when they're recombined, this path of light had a longer path, and this light had a shorter path. So they're going to be out of phase with each other. There's no absolute space in there. It's all completely relative to where it started and where it ended. That's how an interferometer works in relativity. I don't know why this is a difficult thing. So.
Okay, so let's see. We're going to look at now what we have here is a paper by Niklaus and others where they're explicitly talking about the Sagnac effect, and they go over 22 different iterations of people trying to explain it through relativistic confines, making the exact mistake that Toon is currently making right now. So the speed of light is not the same, and it changes proportional to velocity. At least that's what the recorder makes. Otherwise, there wouldn't be a fringe pattern. So all these lads right here, so 14, 25, 28, 10, 20, all these people, right, are all trying to explain why there's a fringe shift pattern when there shouldn't be, right? Now, they try to explain it through, they say, okay, well, it's uniformly rotating, so it's an acceleration, so special relativity doesn't apply. We got to apply the general theory. Why do we do that? Because we can convert the energy, we can conserve it into a gravitational field, which generates little temporal pockets of link contraction and time dilation, right? But that's obviously insane. So the way that they go over it now, the way that they teach it to people so that they don't understand it, and they talk about it the way that Toon just did, is they show you it as they talk about it like a time displacement. They'll say, well, we'll invoke a geometrically convenient position. We'll put an observer at the center of the rotating device, and compared to an observer at the rim of the device that's rotating, this will be the time differential. So earlier when we looked at the graph that explained space-time separation between an observer in motion and a stationary observer, this is what we're looking at, right? This is what they're invoking to explain it, right? This is what this whole paper is based on. Let's see, ether critiques. So it's Tartaglia 2015. This is what they're talking about. This is what they're going over. They're doing the same thing. They're setting up their geometrically convenient position to talk about it, but they can't explain the actual fringe, dog. It's literally not how you said. Otherwise, the technology wouldn't produce a fringe shift, right? The best you could get would be a second order Doppler shift. You wouldn't have a physical displacement that you could measure that would be proportional to the velocity, right? All right. So
Well,
that's
I disagree, dog.
noted.
We should stay on this and see if we can get to the bottom of it. I mean,
Yeah.
we shouldn't
I
have
mean,
any disagreement about this.
It takes time. It takes time for light to travel. And the apparatus moves during that time, and one of the paths is shorter and one is longer. This is, I don't know what this paper that you're talking about has any problem with. This isn't that difficult to understand.
Mm-hmm. Yeah, these are the mainstream explanations of people trying to explain what you're doing right now and holding it up and going, "This is so easy, guys. Why don't you get it?" Well, you should go tell all those guys. You should go tell all those guys.
I don't care about those guys. I don't know why they don't get it either. I don't know. I haven't read it.
Maybe Alan, explain how you also agree that those things get there in different time and how that's maybe help them out there.
Okay, so yeah, light will be measured differently proportional to the velocity of an observer. Okay, and that's the way that every other wave is measured, right? They say that light is special and that it's independent of all this, right? So when they tried to apply this to their equations and everything, they were like, okay, we can do all these kinematics to it, and it's all nice. And then Sagnac came along and showed that it doesn't function that way, right? Because if it did, there wouldn't be a fringe displacement. There wouldn't be a gap in the light. It would recombine at the same with the same phase, right? There would be no displacement to be proportional.
Why would there not be? When one of the paths is longer than the other, they're going to be out of phase with each other.
Because they're traveling the same distance though.
They're not traveling the same distance. One is traveling longer than the other because the apparatus moves while it's in flight.
If the speed, dude, it goes in both directions, dog. Do you know that?
Yeah, and one gets shorter, one gets longer.
And if that happens and the speed of light's the same, what happens when it recombines?
Then they're out of phase with each other.
No, they'll be in phase with each other.
Why? Because the one had a different path than the other.
No, they both complete the same distance.
No, they don't. They have different distance that they travel.
Yeah.
Unless it's stationary. But if it's moving, then while the light is moving through the apparatus, one has to take a longer path than the other to get to the point where they mingle.
I got you real quick. So let's see. I think I see where the confusion's at, bro. Let's see what we can do here for you. 1 second. Okay, so we have here the old Sagnac equation, right? Delta T 4 omega A over C squared, right? And we have the linear version, delta T 2 VL over C lambda, right? So in this equation, right, you do this in the lab frame, the lab will fill this out, right? He's going to make a prediction based off of a rotating device. And then what's going to happen is that device is going to rotate. There's going to be a displacement based off of this information right here. So when the device is stationary and the area of the device is fixed, right, and the rotation rate is, fixed because they know how fast they're rotating it, the area doesn't change, and when it's rotating, the area doesn't change, right? The lab frame prediction and the prediction prediction on
omega is the motion.
There's no,
so when it's not moving, omega 0, the whole equation turns to 0.
right.
Yeah.
So listen though, dog. This equation there's no like separate interval where they're like, okay, well, we have to account for the displacement for the rotating observer or anything like that, so that there's going to be a different so that this area changes, right?
The area doesn't change.
Prediction.
Omega changes.
Doesn't matter.
Why doesn't it matter? It's right there in the equation.
The distance stays the same, dog.
No, it doesn't.
Yes.
The distance is different, and your linear version does the same thing.
And what happens to this? And what is the speed of light doing? Is it traveling the same speed while this is rotating or not?
Yes, it's traveling at the same speed, and since it moved in the process, hold on, Alan. While it was moving at the same speed in both the paths, the distance changed. One path got longer, the other path got shorter. The point where they're recombined moved toward one of the light paths and moved away from the other light path.
And if they're moving at the same speed, they would recombine, right?
No, because you can determine how long it takes light to travel based on the path length. It's a simple part of the equation, right?
Where in the equation is the change in path length noted?
It's not in this equation.
Where's there a different area?
Where's there a different area? The area is not changing, Alan. The area is the same.
I know.
It's the rotation.
You need to understand that. Because if the speed of light's the same, and if that's rotating and it recombines, then there's not going to be a fringe displacement, dog. It only works if it's measuring a variance relative to their velocity.
Light is consistent at this in both reference frames, and one reference frame is longer, and one path is longer, and the other path is shorter, then they won't get there at the same time.
You're grossly arguing against special relativity by invoking absolute space to even.
No, there's no absolute space. It's all relative, completely relative. There's no absolute space here. I didn't reference absolute space. There's a relative difference here and a relative difference here.
Do you see it? It's right here.
The speed of light is not absolute space, Alan.
Velocity, right? Ratioed against the speed of light
within the reference frame, Alan.
What's the reference frame of the speed of light? Is it is it absolute space? These are the exact concepts that they were talking about all these years ago when they were doing this, right? This is a complete falsification of relativity theory. And all
you're doing is you're repeatedly saying that these different paths are the same length somehow. That's what you're saying. That these different paths are the same length. That's what you're saying, Alan, right?
Relative to what?
To each other.
To each other, dog. All right.
They're relative to each other, different lengths, right? Yes or no?
No, they're the same length, dog. What are you talking about?
Different lengths, Alan. Why are you saying that's a different length?
Wait. Do you bet. So you think that it recombines at a different spot like that? Like what the I don't understand.
The place where they recombined moved since the light was emitted.
But the speed's the same, so I guess it caught up in time just to make not a fringe pattern. So anyway, we got 2 minutes left.
They still have a fringe pattern.
No, it wouldn't. So we're going to the biggest circle jerk ever. I think we both said the same thing that we need to. We can move on to another subject now if you'd like. I'm not interested in continuing.
Yeah, I'm not sure we'll get anywhere.
Yeah.
There. Whatever topics you want.
How does an interferometer work, Alan?
It splits a light beam and it recombines after completing a circuit.
Okay, and then why is there a fringe pattern?
Well, so there will be velocity, right? And that causes the fringe shift pattern to be measured, right?
what's causing a different velocity?
The motion of the apparatus.
Yeah. But I don't understand why a consistent speed of light and a moving apparatus, it doesn't work for you. Why do you think that's a problem?
Because they would complete the circuit at the same time on both sides and
No,
not
they
produce a
wouldn't.
fringe.
No, they
Yes.
wouldn't. One got longer.
Nope.
I don't see why you think that that didn't get longer.
Hmm. I mean,
Why? I mean, this diagram do you not see that this one is shorter than that one?
yeah, I can understand like what you're saying.
Okay,
but
and
you don't-
there's
but you don't
an
understand
amount.
what-
Hold on,
but,
and there's
like,
an
the
amount
issue
of
here is-
time from
Mhm.
when they're split until they're recombined. There's a delta t in there.
Yes.
And during that delta t, the apparatus is moving.
Yes, they do describe it with a delta t, but
Okay.
the delta t cannot describe the actual fringe pattern displacement, dog. This is part of like the confusion for it, and especially with removing the general relativity explanation and putting it back on a time displacement, like as if they're accounting for it with special relativity when it's explicitly not, right? So all these gentlemen that we just went over, all the modern papers that still can't explain it, they can't explain the linearization of the Sagnac effect, but
I just explained it.
you
Amazing. And the
while invoking-
linearization was also explained. It's pretty
Do
cool.
not interrupt me. You, while invoking absolute space, have not explained a single thing, and you've gone contrary to relativity theory.
I mean, I'm just right in line with it. I don't know why you're saying that.
Are we confused whether or not the device is moving itself? Or are you? I guess that's
I
probably-
don't know.
Or are you saying that the Earth is moving, causing that displacement? Or are you saying
No,
that
no.
the device
No.
itself?
He's saying that the distance of the device is changing as it rotates, which you could look at it that way, right? But that's invoking absolute space, which Einstein explicitly said.
No, it's not.
It doesn't.
It's not
Yes.
invoking absolute space.
Listen, guy. Don't interrupt me because of your lack of understanding. If I'm talking, just sit there quietly and laugh. Okay.
Oh, the
Right?
condescension
Just
comes
do
out,
that.
Alan. You don't need to do that, dude. You're better.
You've been doing it to me a lot, and I'm trying to talk, and it's frustrating. So if I get a little condescension with you, just mute your mic and sit there and smirk, okay?
Alan, go ahead. You guys want to go to your closings? Or you still have more?
Yes, I got you on the closing, dog. So for my closing, I would like to show that no substantial mechanism was provided to substantiate that relativity theory is the correct interpretation of the behavior of light or gravitational effects and that or the motion of celestial bodies. It all turns out to be kinematics in the lab frame where you can actually do measurements. You can show that there's a variance in the speed of light, which produces a fringe shift pattern, and that would not be possible if the distance and time were changing as noted or as they're trying to denote, right? And I think that's about it.
All right. Well, I showed that there are many millions of measurements of the shift in the light, the light deflection going all the way out to just underneath 180 degrees from the sun, consistent with general relativity. And Alan did not provide a plausible mechanism for why it happens. The Dowdy version of it is that the sun is causing refraction, but the sun's clearly not causing refraction that far away from it. So anyway, thank you very much, Alan. Sorry if we got a little hot there, but
No worries.
it's good. It's all good.
All in good fun.
Much-
I think it
much
causes
appreciated.
people to go out and have to do more looking into things so that they understand it better, because I may be more confused than coming in here. So that's never a good thing. Let's see here. We're going to get to super chats right now. So get those in. You can either go to Rockfin, send them in if you have a question for Toon or Alan, and we'll get to those right now. Did you guys see Bill Nelson talk about the dark side of the moon? It's pretty funny. Just for
Is he in Pink Floyd?
no, Bill Nelson is the head of NASA, and
But how's his saxophone playing?
what
How's his saxophone playing?
does he play saxophone?
I don't know, but one of the guys in Pink Floyd does.
Well, this guy Pink Floyd probably knows more about the moon than the head of NASA. That's all I'm saying.
I don't know what you're talking about. What did he say?
I'll play it for you. Here we go. Well, listen to this. This is just real short, 44 seconds.
Doing things on the backside of the moon. Do you have any insights in
I
that?
can't really hear it.
Sorry.
Going to have a lander on the.
So he's asking about China going to the moon.
What's the Chinese are doing, you think, on the backside of the moon? Do you have any
Well,
insights in that?
They are
going to have a lander on the far side of the moon, which is the side that's always in dark. We're not planning to go there. And why not? And what's the benefit of doing so?
Just to say, he made the faux pas about calling the backside of the moon that it's always dark.
But that's his reason why NASA's not going there. It's always dark. We don't go there. When
Yeah.
It's always dark.
Yeah.
He's the head of NASA.
Yeah.
Just saying, at least flat earthers know the model. Now they can say they know the model better than the head of NASA. It's kind of funny. All right, we're going to super chats. Let's see who we got. Let me bring you guys back up on screen. Good old Bill Nelson. He's supposedly been to space, by the way. So he says. Let's go with this screen here. See if we've got any. Thank you guys for your support. Let's see what we got. We've got. Oops, that's not the right one. Fan funding. There we go. All right, we've got up first. Let's go, Dad, says James Brown. Let's go, Dad. All right. Anybody get that one? I'll get it. How about we've got MPE. Thanks for being a member for 18 months. We've got Justin Johnson gifted 5 memberships. We've got LJ for $2 says, why wasn't the lunar lander ever tested on Earth first? Assuming that's for Toon.
I don't know why you think it wasn't tested. Of course they tested it. Well, what kind of testing would you think that they did not do that they should have done? Maybe Jeran can suss out what he was thinking about.
Well, probably because the lunar lander wasn't made to be on Earth, is my guess. But
Yeah,
they tested a version of it.
Do you think they could test that it holds pressure by putting it in a vacuum chamber? I don't know if they did or did not. I'd figure that they probably did, but I would do it if I was in charge.
Yes.
But I don't know what other testing you specifically you might think would happen. But
I don't know. All right. I don't know what he meant by that. But we've got Sharon is Karen. Thanks, Sharon. Thanks, James Brown. Thanks, Dad. Again, we got Eugene Austin says, McToon, did you really just say the words? I don't think you've read up enough to Alan. He literally has segments on his channel specifically for reading. My boy probably reads more than you breathe.
Well, Alan did confirm that he had not seen the one I was talking about.
Okay. We've got
it's on my website, mc2.net. Just search for Deflection. You'll find all the papers I was mentioning.
Yeah, we got Witsy Gets It, $5. Thank you very much. Says, yikes, Toon got completely washed. Shout out to Alan. Hey, Toon, can you attribute physical properties to conceptual abstractions? Isn't that reification?
No, that's a straw man. That's what that is, Austin. Thank you, though.
Okay, thank you. We got Upside Down Guy, $5. Says, Toonies, how can we confirm the sun is not 4,000 times as big and 4,000 times as far as the moon? Or 4 times as big and 4 times as far?
How can we confirm that? Well, multiple people have measured the distance to the sun. I could go over that, but I don't think you want to go over that right now. But you can bounce radar off of it and time it. It's one way.
We've got Upside Down Guy again. How close would a space pirate need to be ejected out in an airlock? Sorry, let me try this again.
Oh, that sounds fun.
How close would a space pirate need to be ejected out an airlock for a fart of theirs released in space would be pulled back to Earth?
For their fart, or for them to use their fart to propel themselves back to Earth? I like that part better, but I think they're talking about the fart going back to Earth. But if it's inside the gravity well of the Earth, it's going to eventually those methane particles will mostly find their way back to the Earth, unless they aimed their butt away and pushed hard.
Okay. One of the dumber things.
I love that question.
I guess. Toon, can you, just for me, I like to give it a little question. Do you think E equals MC squared is smart?
Yes, it's smart.
And can you explain it for us, just as dumbed down as possible?
It is the mass energy equivalence. So, and this goes right to, I was going to talk about this, but I left it out. Too much math, but it's the mass energy equivalence of light, that even though light is massless, it has an equivalence to it. Therefore, it is affected by a gravitational well. So a single photon of light has a frequency. That's the, you can determine the mass of that. So E is energy, but E is also h nu. So you can plug that in. You can actually get the mass of equivalent mass of a photon.
All right. Sounds good. Anything? Oh, Rockfin. Sorry, one more time. We're almost done. Almost out of here. I forgot about one other spot. Let's check out who's in Rockfin. Thank you guys for being here. Appreciate it. We've got a couple. Let's see what we got. How about Fishhead, Montana? Says for Tune, where exactly does Alan's interpretation of the fringe shift fall apart, and what is your explanation for that shift?
I think we got into that though, didn't we, Alan?
Let's see if you can answer the question as place. So where exactly does Alan's interpretation of the fringe shift fall apart? Well, I guess you've explained that. You say it moves. Okay.
Yeah, it's
and
moving.
What's your explanation for that shift?
Yeah, my explanation is that it moved while the light was moving through the apparatus, and I think Alan is saying that the speed of light changed because the apparatus has a speed that it pushed to it, when it was moving or something, right?
So I guess where I'm getting lost is that I know that they measure the interferometer on a moving Earth, supposedly, and then also they tried to move it on a platform, right?
Yeah. So
Do they see the same thing in both cases? When they move it on a platform, do they get the same result as when they do it on Earth?
It depends on the precision of the interferometer, right? You need a higher precision interferometer to measure the Earth's rotation than moving it quickly yourself in a lab.
Yeah,
Right.
I guess where I'm confused is you're describing it as it moves, the path changes. So what is that measuring then? If it's moving, that's the reason for the fringe shift.
Yeah. So yeah, the faster it moves, the more the difference in the arrival time of that same frequency, the same photon.
Yeah.
Right?
Yeah. So
But that's what I
Jeran,
thought.
their interpretation of it would be like for a stationary interferometer on Earth would be that it's Earth's rotation that's doing it, and they're measuring. So they don't invoke absolute space for linear motion, right? But they do for angular. So they're saying they're measuring like a finite rotation point, and that intersects in the middle of Earth at 15 degrees per hour, right? So that's how they would attribute it to it. But it doesn't tell you if the Earth's rotating or if there's an ether wind or sky that's rotating. But anyway, that's how it works for them. So they would say that like literally that the Earth is rotating from underneath the light, and that's causing the fringe displacement. Although that would require a north-south variance, and there's none of that. So that's super unfortunate for the Earth rotating, lads.
And your question would be, can you explain the Sagnac effect then?
Me or two?
You.
Yeah. So the Sagnac effect is when you take a light beam, you split it coherently, or I'm sorry, you split it such that it recombines in a circuit going opposite directions to one another. When it recombines, a fringe shift pattern will be produced if proportional to the velocity of the apparatus.
Sounds good.
So,
All right, guys.
so on the a interferometer that's precise enough, sitting fixed to the surface of the Earth, gets a fringe shift. Why is that happening?
Ether wind.
Now, is ether wind possible inside of a metal container?
Well, that's a good question. So there is a slight measurement in there, but the periodicity that you can measure through the fluctuations is reduced greatly through it. And what was found through experimentation in the 1900s and I'm sorry, not 1900s, 1920s to 1930 from Miller was that when you hermetically seal the device or you use Fermi surfaces to shield it, that actually blocks the readings. So that shouldn't happen because that's showing that light has a hydrodynamic response, right?
But, Alan, you know that the most precise interferometers that are measuring the Earth's rotation are in sealed metal containers underground. How are they measuring rotation?
There's still a fringe pattern displacement, and those also use they use a medium in the tubes as well. So, like, are you familiar with the Ginger project and all that?
Yeah. It's
So
inside
to
the
get-
thing. It's inside the thing that you said blocks the ether wind.
Well, it doesn't
Right?
block it. It doesn't block it entirely. There's still measurements. You can still get periodicity out of the measurements too. It greatly.
But you
reduces
said
it,
you
right?
said it.
No.
Does
I
it
didn't
block it
say
or
that.
not block it? It seems inconsistent there, Alan.
It greatly reduces it. You can look at Miller's work and Yuri Galev's work, where they show that light responds hydrodynamically according to the shielding that's used. Right. So, and also the medium that it's propagating through. So when they do it in a vacuum, hermetically sealed in a basement, they get almost no fringe displacement and no periodicity within the measurement. Right.
But they do.
It's very, very
But they
reduced,
do.
but
They
it's-
get they get 15 degrees per hour times sine or cosine of the latitude, right?
I feel like you're not understanding what I'm saying. I'm agreeing. I'm saying that there's a periodicity that they
But-
also measure.
But
That's daily
yeah,
fluctuations.
But
But-
you're saying that the
what?
ether wind can't get in there.
Who said that?
Miller, you.
Miller said it greatly reduces it. It doesn't say it doesn't get in there, dog.
All right.
All right.
I mean, I've read Miller enough times to know what he said about it. I've read Gallow's papers enough time to know what he said about it. Never said it doesn't get in there. I said it greatly reduces the effects. When you go to altitude and use things that aren't Fermi surfaces for the shielding, you get increased velocity, right? Yuri Gallov showed that too. Right. So we have corroborative evidence that there's a vertical velocity gradient, right? So if the Earth is rotating, when you take interferometry readings at altitude, it should still be 15 degrees per hour because you're invoking the measurement with respect to absolute space of a, hypothetically rotating center point, right? Not an actual mechanism that affects the speed of light.
Okay, final super chat says, interesting to see how people can justify their BS. Don't have to read. Alan for the win, other than the dog responses. So they gave you a loss for that. All right, let's head out of here. We got a debate tomorrow, 3 p.m., I believe. I should probably check that, but I believe it's a 3 Pacific, and that will be Ozian against Shane St. Pierre. I'm just going to make sure the time that I have correct. And it is at 3 p.m. Pacific. All right. So that is St. Pierre tomorrow and Ozian. I forgot the topic, but I'm thinking it's
Tides.
thank you, tides. That's it. Should be fun. All right, guys. We will see you tomorrow. Do your own research. When you do, you'll never again believe all the bullshit you've been taught. Thank you, Toon. Thank you, Alan. We'll see you guys next time. This has been
Thank you
Jeranism.
guys.
All right, we'll see you.
Appreciate it.
Peace.
All right. Thanks. All right. Well, this is interesting. Very, very interesting. What is the I had that one in my pocket. So he says this is critical, absolutely vital for his position on relativity. He says that Michelson-Morley read a very small pattern because they did it in a basement. It was not in a metal container, and he thinks that they had a small fringe shift. It doesn't actually match the predicted in the direction. It's not a good match. It's not just a smaller amount than expected. It's a mismatch. But he says this is critical, that the ether can't get through. He said hermetically sealed. He said Fermi surfaces, that it can't get through them, and that's why Dayton Miller did all of his work on top of a mountain, and he did it in. He had windows and he had tarps and things like that. So it's an absolute. It doesn't work, right? Because you can take a Sagnac interferometer and bring it to the top of a mountain and have it not in a metal container, it's going to measure 15 degrees an hour. You can bring it underground inside of a metal container and it'll read 15 degrees per hour if it's a 3-axis gyro. But he didn't like that. He didn't like that. So, and I get that. He totally had to bail on that. I know that he has an answer to it, but it's complete BS. It's absolute total BS. He says that the ether is blocked by things like that, yet when they're inside of things like that, it still measures the same as when they're not, when you have a Sagnac interferometer measuring rotation. So, all right, let me read a few things here. And then I'll do a little review as I go through this here, thinking back about it. Ask him to explain Einstein's cross. Said Tim Davidson. Einstein's cross got an instant runaway from him. Instant. This is the important thing. He has not seen Dayton Miller's data. He has not seen the fringe shifts that Dayton Miller measured, but he accepts them. But since he hasn't seen the Einstein's cross, he rejects that. That's the inconsistency in the standard of evidence. It's a standard part of science deniers. I don't have the book handy, but Speaking with Science Deniers by McElroy, I forgot his name. Anyway, inconsistent standard of evidence. It's the third law of Flerf embodied, that everything I don't like gets rejected. Everything that they do like, they accept. That's it. That's the thing. He reads all these papers. They're all these fringe papers. They don't have backing. Nobody talks about them because they're crap. And he's like, these are the ones that everybody needs to pay attention to, not these thousands of other ones that people have done a lot of work on and actually, controlled for confounding variables on them. Never mind those. So, all right. Grant him relativity debunked so he can explain flat Earth. Well, and that of course is the big thing. And all the flurfs in his chat patting themselves on the back. None of this changes that they don't know what time the sun sets tomorrow. They can't touch that. What time will the sun set? You don't know. Earth is not flat. All right. Lord Illuminous Pooh, the guy that invented lifesavers, became stupid rich. He must be a mint. He made a mint. Oh my gosh. Eric Meyer is a new member at Buzz Aldrin. Thank you very much, Eric Meyer. PhD Tony says the distance to the stars in the analysis Alan referenced is effectively infinite. He may be able to fudge the distance to the sun, but not the stars. And that's the one by Dowdy, right? And Dowdy, I love it when Flurfs reference Dowdy, because that specifically ties them to the sun being something very specific. It's like, oh, it's just the ratios. Okay. It's still a fusion reactor. How's that work? It's a fusion reactor. There isn't enough mass there. Oh, but gravity doesn't even exist according to you. So why is the fusion happening? Right? It falls apart as soon as they reference these things, right? So Dowdy is trying to do away with some, whatever, I don't care. Grant that completely, but it doesn't give you anything. Plus, and he's like, oh, it's only at the limb. There's actually no light measurements at the limb. There have been radio at the limb. The limb is right at the edge. That's grazing, right? The other ones that are multiple solar radii out, he's like, oh yeah, it's that many solar radii out. And seriously, you think it's refraction? That's what Dowdy's talking about. He's claiming it's refraction, but it's not 175 degrees away from the sun when they're still in their margin of error, right? I think it's, if I remember correctly, like 175 degrees from the sun, it's like 20 milliarc seconds is the predicted deflection from the mass of the sun. That's great. Think about this. This is so cool. The sun's there. That direction, light is affected by sun's gravity. That way. Enough that we can measure it. Our measurements are that precise. Pretty cool stuff. So, King Cruz says, Magoo and the King needs his book. Dude, I went to Florida, I went to Texas, I went to Colorado. You weren't there. I had it with me. Lord Illuminous Pooh says, so observational tools don't count as observation. Apparently not. Now, I don't know if Einstein's cross, how it has been imaged. I don't know. But it doesn't matter. All he had was nuh-uh. Joss says someone should press up them and grant all the press ups with only globe axiom would be if we disprove any part of the model, the globe is the correct one. Yep. Oh yeah, Stringer News 1 got a book. All he had to do was show up. You know what? I gave him the book, the 1916 book from Einstein. Gave him that. Also gave one to Will Duffy, who was the host. So I buy them used off Amazon, and I've depleted the supply. I did a while ago. I have none left, so I'll have to go on there again. Don't go buy any. Let me have them. I'll bring them, and I'll give them to you when I meet you all. Shifty Eyes Shady says, I'm just curious, how many people in here saying they won't go to InfoWars poll have actually ever watched anything on InfoWars? You don't have to watch anything on InfoWars to know what they're about. So, all right. From Hubble is Requiem for a Dream. Oh, all right. So that is. So my guess is that he will blindly reject anything from Hubble, because the power of Na'a compels him. So let's, I'll put this up here. There you go. There's the Einstein cross from Hubble. There you go. So yeah, you can't put your eyes to it, therefore Na'a. That's supremely dishonest. Because he references things all the time that he can't do it. He couldn't replace himself. Not reproduce. Mac Fraz says, I think old mate was dropped on his head as a kid, and that's why the bandana's for. Yep, that's it. I don't know. He's definitely brighter than a lot of the flirt. If you go on Facebook and holy cow, you see how dumb they are. Lord of Luminous Pooh says atomic as an atom, clock as in counting. Yeah, I mean, like it's just frequencies, bro. It's just frequencies. And yeah, and then tying it all back to this is the speed of light. So this is the thing. In the atomic clock, he's saying these atomic clock measurements somehow are the speed of light is changing. What's the plausible mechanism causing the speed of light? What's the computation of the consequences of your hypothesis? When was this hypothesis confirmed in an atomic clock reference to be causing a difference in the time, right? So you have two clocks right next to each other, vertically above each other, not moving. How do they tick at different rates? The speed of light? That doesn't explain it. What's causing the speed of light to change? Gravity? Well, that doesn't help you anyway. So what is it then if it's not gravity? Because you definitely won't let it be gravity. What's causing the difference in the clock tick? Nothing. All right. Gareth Bunting says dog. And Lord of Luminous Pooh says knee. Barry F says, I'm serious and stop calling me dog. Surely you can't be serious. Mac Fraz for $7.99 Australian says, please ask him what mind-altering drugs he partakes in. All right. He's not as bad as others. You wait until Friday. Oh my gosh. Borg Emporia says, will MC2 never do a collab with the mighty Dapper Dinosaur so I can stop splitting my attention between two streams every Tuesday night? I would do that. We don't cover the same stuff very much though. Do we? I don't know. I don't watch him much. I've seen a few, but he's fine. All right. 3 Run says your forehead must be injured from all the face palms. Yeah. Wear facepalm protection. Stringer News 1 says tonight's sponsor once again is Preparation H. Lord of Luminous Boost's chat. Who's worse, Ross or this guy? I would say it's Ross, but I will put the poll up. All right. There you go. You can choose. William Foley, has Alan booked his flight to Stockholm yet? Stockholm, Sweden. I don't know what that's about. I'm missing that. Lord of Luminous Pooh says, seeing Ross. Yeah, Ross. I go through. Oh yeah, Ross is Ross is winning 81-19. Yeah. All right. What's the... Oh, for the Nobel Prize. Yes. Well, no, he's not done it. He's citing other people. So maybe Wang should get the Ruyan Wang. You know what I was reading? I posted it earlier. Ruyan Wang, his... Oh my gosh, his paper on GPS and I read it. I'm like, he can't be serious. He just made this it was a blunder like this, right? Like, I don't see how Alan thinks that the path didn't change in length while the light was moving. How is that not? How do you reject that? And then claiming relativity would not agree with that. Like, it's invoking absolute space. No, I'm not. He did reference later that rotation is absolute, and yes, it is. That's not in contradiction with relative space, because relative space is about acceleration. Not moving? Moving. The apparatus moved while the light was in flight, and the path is longer. That's relativity. You're like, it contradicts relativity. No, it doesn't. He's like, oh, this paper by people said that it's hard to explain. I don't know. Maybe at different levels it is. I'm not trying to explain it at a deep level. My Mom Bakes Cake says, Dog's Day Out, the dog, Alan, was trained by Witsit Word Salad Generator 2000, patent pending. Yes. And William Foley, absolutely, he lost all credibility when he quoted Ken Wheeler. So yeah, this Ken Wheeler likes his flower of life and his magnetic. So what he has this this 2 layers of plastic or something, and inside of it he has a material, and there's iron in there, right? He calls it a ferrocell. And then when you put a magnetic field to it, you can see patterns in the ferrocell. And somehow that has some meaning beyond what it actually means. What's happening there is not a marvel to people that understand the topic. It is not the magnetic field affecting light. It's the magnetic field affecting the medium through which the light travels. And that's what you're seeing, is that the medium has been affected by the magnetism, not the light. So yes, if you quote Ken Wheeler, you're a loony. CJ Lamoureux says Ross Kingpo Flurf or Alan Dog for top left. Yeah, we need to finish the top left stuff. We don't have all the videos in, so I've been busy this last week. So hopefully coming up I can get that. We're gonna be in May before we're gonna start voting. It's okay. Cece can continue to reign as the king. So we got Ross. Dave Lister says Ross is more obnoxious, but Alan is worse because he's more well-read and so should know better. Should being the operative word. Yeah. So I'm gonna show this one again. Here is the experiment where Alan declared that the speed of light somehow changed in these different samples, right? So you see these 5 different samples in the optical lattice. And then you've got something measuring the clock as they, and measuring that different ones tick at different rates based on how high they are. So they're vertically separated by 1 centimeter from top to bottom of this diagram. And you see over on the left side there, 0 centimeter, 0.25 centimeter, 5 centimeter, 0.75, and 1.0 centimeters. So this is the setup. It's inside a Faraday cage, so it can't be an electrostatic change. They're controlled for temperature, so it's not due to temperature. I don't know what is the thing that would change the speed of light for this. What in there is changing the speed of light so that the measurements are different? No idea. No idea at all. He just said, "Nuh-uh. It's something else. Let's change the topic to talk about speed of light. How is speed of light affecting this? How? Just go ahead. Where's the experiment that confirmed this? Oh, let's talk about interferometers. This is not an interferometer. There's no interferometer involved in this. It's stationary. It's not moving. It's inside a Faraday cage. Nothing is according to what all of the different things that he's talked about. None of those are here. None of them. All right. So let's finish this poll. 127 votes. That's enough. We got 79% say Ross is worse and 20% say Alan is worse, giving 1% margin of error. So, all right. Here's what I'm going to do. I'm going to move up the other one. I'm going to do it right now while I'm here. The one of Witsit. So I have another one coming, and it's Witsit. Witsit's debate from earlier today. So I'm going to move it up to 10:30 from 11 o'clock. So I thought it'd go longer on Jeran's. It did not. So there it is. So get ready for that. Yeah, no such thing as ether wind. Anyway, people, thank you very much for joining. I'm going to play the way outdated member list. I do need to update this, but thank you everybody. Be sure to check around in about 15 minutes. Also, I got 2 debates on Friday. Don't miss them. We'll see you then. Here we go.
MC2, drop that beat.
All right, let it flow. Let yourself go. So I know that is the tempo.
So, yeah, let's do this. So,
Let's do this. Yo, it's MC2, the debunking tycoon. I shatter flat earthers, make them face the moon. Your attempts are decent, but they'll swoon in the face of my logic like a deflated balloon.
Oh, MC2, the monsoon of cartoons. I'm the real sage, send it first to their views. Your theories are like old brooms, sweeping ignorance or just spreading the views.
FDFB stands for fumbling the facts, evidently. I drop truth bombs so splendidly. Your approach is soft, mine's unrelenting. I bring the science while you're just venting.
MC2, the buffoon with silver spoon. I tackle pseudoscience, make them change their tune. You're the sidekick, I'm the room. When it comes to debunking, I'm the room.
But hey, FDFE, we share the creed to educate and debunk the plant the seed. Though in this rap, it's clear indeed I've got the upper hand in word and deed. All right, hold on a second. The Zoom call died. Everything died. No.